Welcome, everyone. Today, we're diving deep into a crucial aspect of modern system reliability, intelligent alert management. We're moving beyond simple notifications to build a platform that acts like a Google search for your operational alerts. Think about the efficiency gains when you can instantly find exactly what you need amidst thousands of alerts. By the end of this lesson, you will be able to, first, understand how to transform a basic alert system into a sophisticated query and management platform. Second, we'll explore the key architectural components necessary for advanced search, bulk operations, and real-time insights. Third, you'll grasp the principles behind real-time query processing and how to implement robust bulk alert operations. And finally, we'll cover critical production considerations to ensure your alert management system is not just functional, but resilient and scalable. Let's get started. Why does an intelligent alert management system truly matter in a production environment? Imagine a large social network monitoring millions of requests per second. They don't just need to know when something goes wrong, they need to find the right alerts instantly. When you have thousands of active alerts, trying to manually sift through them for, say, critical database alerts from the last 4 hours that are still unresolved is a recipe for disaster during an incident. Without proper query capabilities, engineers waste precious minutes, turning a minor issue into a major outage. Companies like Datadog and PagerDuty have built their entire business models around the idea that intelligent alert management is not a luxury, but a necessity. The true power of a monitoring system isn't just generating alerts, it's making them findable and actionable. This shift from passive notification to active management is what empowers teams to respond effectively and minimize downtime. Let's break down the core architecture of our intelligent query and management system. It acts as the central intelligence layer, sitting between your raw alerts and the human operators who need to act on them. At its heart is the query engine. This component is responsible for handling those complex queries with multiple filters, allowing you to pinpoint specific alerts with precision. Working closely with it is the index manager. This component continuously maintains searchable indexes for your alert data, ensuring lightning-fast retrieval when a query comes in. Think of it like building a highly optimized index for a massive library. For dealing with large volumes of alerts, we have the bulk processor. This manages batch operations, allowing you to acknowledge, resolve, or suppress thousands of alerts simultaneously without overwhelming the system. Finally, the statistics aggregator computes real-time metrics and trends, providing immediate insights into your alert landscape, helping you understand patterns and identify potential issues before they escalate. Now, let's trace how alerts flow through our system and how we achieve those lightning-fast queries. The system operates on a classic producer-consumer pattern. Alerts arrive at the ingestion layer from various sources and then flow through several processing stages. Next, the indexing pipeline takes over. This critical stage creates searchable indexes based on various dimensions like status, time, severity, and custom tags. This pre-processing is what makes rapid searching possible. The query engine then employs a multi-dimensional indexing strategy. When you search for, say, critical alerts in the last hour, it simultaneously checks time-based, severity, and status indexes. This parallel lookup is key to achieving sub-millisecond query responses, even with millions of alerts. Crucially, the control flow is designed so that search queries never block the alert ingestion process. This ensures that the system remains responsive and can handle heavy alert loads without impacting its ability to receive new critical events. Beyond just querying, managing alerts efficiently means handling them in bulk. Our bulk operations engine uses a robust state machine pattern. Operations move through states like queued, processing, paused, completed, or failed. This ensures that even when you're making changes to thousands of alerts, the system remains stable and consistent, preventing partial updates or errors from leaving it in a bad state. The export and statistics layer is equally vital. It generates various output formats like JSON, CSV, or PDF reports for analysis, while real-time statistics are computed incrementally using sophisticated algorithms similar to how trending topics are calculated on social media platforms. This entire component serves as an operational intelligence layer, integrating seamlessly with other infrastructure management tools. It connects alert data with incident response workflows, capacity planning systems, and even automation triggering mechanisms, making your entire infrastructure more intelligent and responsive. Finally, when deploying to production, consider index size management to prevent unbounded growth. Implement query performance safeguards like circuit breakers, ensure data consistency even during high ingestion, and establish robust access control for sensitive alert data. By understanding these elements, you're not just building a system, you're building a foundation for operational excellence. What's one critical production consideration you'd prioritize for a new alert management system? And why?